there will not, this, I mean, this is not, I'm not Harrison Ford. So I have more like questions than answers. But this is about inspiring people to use the Dyalog' APL programming language as an extension to your mind. There are a huge amount of things you can do. If you're curious and creative, go ahead, grab APL from the Dyalog' website and begin coding. We will be working, yes, on another ship. And it seems each time I have a presentation, I seem to go back in time, more or less. So in a future presentation, I shall try to go ahead in time instead, but not yet. 552 years ago, something happened. Grab your problem, go attack it, extend your mind with APL. Why old ships? Well, they are historical importance. They are a challenge, and occasionally they may contain interesting stuff. Like in this case, we talk about some 100 million euros. Maybe. In order to understand, I must give you an overview of the political situation 550 years ago. We had, starting from the bottom of the screen, Lübeck, the Hanseatic League. It was a legal union of merchants, trading people, realizing that there is a lot of stuff to buy and sell. A bit more north, we had Sweden and Russia, who used to fight with each other on Finnish ground. And down left, we have the Danes, who were an annoyance to everyone nearby. They just love to drink their beer and have fun and steal money from other people. They are like a plug here in the Baltic Sea opening. You cannot get in, you cannot get out without passing the Danes. And they even they built a castle named Kronborg in order to stop all ships and take part of the cargo, just for fun. Yeah. Lübeck, built at the Trave River here. We had the Baltic Sea up in the upper corner part of the screen, where the Trave River comes out, Travemünde. The people in 1468 in Lübeck saw something rare. Big ship, bigger than anything seen before. It was the Hanneke Vrome. The captain's name was Hanneke Vrome, and the ship had the same name. A big one. Could have been something like this, we don't know. They were supposed to transport stuff from Lübeck to Reval, Tallinn these days, the capital of Estonia. 4 ships in a row, 3 as escort against the Danish pirates. Aim, go to Stockholm, go to Reval, that's it. They went very late in the year, in November, because of the pirates. Usually ships never leave that late. On board, 1,200 barrels of honey, lots of gold as payment for earlier delivered stuff, and new goods to be delivered to Estonia. And what is Reval? It's a beautiful city. Here's on an old painting, and here's how it is today. Maybe you see the similarities. It's the same buildings. The ship came, but there was a problem. If you have a storm, wind from south, you cannot enter a port going towards the wind. So they decided to continue to Finland, where they were supposed to go anyway. 2 ships, the Hanneke and an escort. But the Hanneke ship capsized. We have a story telling the smaller ship managed to come back and tell what happened. But you can see here in the picture, the Finnish coast, the north side, is full of shallow waters. Very dangerous. Comparing to today, there were like 16 times less people in Scandinavia. And there were 220 casualties in the Hanneke accident. Converted to today, it would be 3,500. And compare that to Estonia, 852. Estonia was, by the way, the biggest post-war, post-Second World War accident in Europe. So the Hanneke accident was a big one. The aim was, when going towards Finland, to go to the Raseborg Castle, the Swedish representation in Finland. Finland belonged to Sweden at those days. And notice there is water around the castle and sail ships. No water any longer. And this is because land is rising in Scandinavia all time, each year. And in fact, that castle is far away from the coast these days. What do we have? An old story. The Hansa people were good at documenting everything. They were traders and businessmen. Old maps, no go. They don't help us much. They didn't know anything about, really, about the Baltic Sea. Even Norway, Denmark, and UK are wrongly painted here in this old woodcut. They merely traveled along the coasts and used directions. Like if you want to go to another city, you take that direction and then you wish you come there in some amount of time. The Danes were good at checking out places, and there is something called the Danish itinerary, King Valdemar's sailing route from 1230. It was an expedition along Sweden, Finland to Estonia, where they wrote down 101 route points. This is very useful in getting the mindset to medieval times. But from this image, it's the Carta Marina from around 1500. We can see that everything is wrong, actually. It's totally wrong. Now back in time a little again. Ice Age, as you know. The center of the Ice Age was between Finland and Sweden at the Swedish city of Luleå, where there were so much ice, 2 kilometers of ice, that it pressed down the Earth's surface. And it is still rising 1 centimeter a year, also this year. At the location of the Hanneke accident, it is about 4 millimeters a year. Count that times 550 years and we get between 2 and 3 meters. In addition, the sea bottoms have been stuffed with all kind of material, so we can count another 2 to 3 meters of less ground at those times. So we talk about 5 meters difference, 1 meter per 100 years. Magnetic arrows, the North Pole and the South Pole are going to change place in a not so distant future. And it has changed place or traveled all over many times before. They could use compasses. They could see the sun, calculate the sun height and so on. So they weren't totally lost, but that's something we cannot compare today's magnetic courses with them from those from these days. Force vectors, we have a ship, we have a sail, and this is all for preparing for calculations of what we actually can do to reconstruct the travel later on. If you have a ship going ahead, wind from left, you get, and the sail, the black line, you get the force. If there is no friction, it will be in that direction, and it consists of two components, one side component and one ahead component. This is why a ship moves forward. And this is lots of modeling in making that right. Other parameters are, for example, that the Earth is round, and there's a limit to how far you can see. If you have a ship or a point 30 meters above the sea, you are able to see a tower that is for 30 meters above the sea at a distance of 40 kilometers. Other clues from this accident, there were no survivors, meaning that if the accident had taken place nearby a shoreline, there would be survivors. So we can exclude those places because there were no survivors. Everything that helps to minimize the area is useful. There were human behavior. For example, false fires, of goods. There was a very thin line between helping and stealing. And the people along the coasts, they used to pray for a ship for the winter to get some addition to their storages. And if you lit up a false fire, you may just be able to get the ship to come here by mistake. Money, hurry, same as the factors in last year's Irma presentation. All things that affect your decision making. Demanding passengers. Also, the castle's wife, the castle lord's wife and son were on board, and they were all blue-blooded people. Very, very important. Sailing at night, fear, God fear. That's important, maybe. So what do we have to use? We have something called the European Union Copernicus Weather Analysis Program. And it is about a webpage here. Copernicus, I hope you can see it's not the biggest possible font, of course, but and you don't need to read it. But it says here, well, it says here European Union. And more precisely, what we want to use is the Reanalysis. This one here, provide the most complete picture of currently possible or past weather and climate. It's a recalculation of the weather all over Earth. And the download page is rather easy to use. I select Reanalysis. I have selected already some data. U component of wind, V component of wind. There's much more. I can take a look at the snow, for example, and snow density or many, many different parameters. I've checkmarked mean wave direction, wave period, significant height or combined waves, I want to get statistical basis for estimating how the ship long ago, what kind of environment did it have. So I would, in this case, select all years available for data, and I would select November month, of course, as it was in November. I would select all days in November and all times in November. I would enter here a position covering the Baltic Sea, select a format and send a request for data. And having a small look at this GRIB format. What is GRIB? Well, it's the format the weather guys use. They love it. It's highly efficient, written long ago, improved, and they don't waste a bit. Meaning self-describing, compact, portable, blah, 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 which makes it a bit tricky because on the other hand, the data is very near APL. It's multidimensional data, but as the rest of the world don't have any APL component files, they have invented all kinds of smart solutions to transport data. Luckily, after doing thorough searches, I found a converter. I only wanted an executable that takes a GRIB file that I would have got downloaded from the weather site. They are like less than 100 megabytes, and convert that, decompose that into APL data. And after searching lots of different places, most of which want you to download an entire set of functionality, I found this WGRIB2 at the NOAA site, NOAA. And this does the job of converting. I'll show you just a little bit of APL code here. Some parameters in variables and a command line call, CMD, calling WGRIB.exe with a number of parameters and getting an output file here. I call it bin because it will be 32-bit floating point data. Calling the command line, reading the result binary file as data type 323, and of course I want it to floating point values, and the best way to convert the floats is to use the Dyalog's mem copy, which takes 4 bytes in and pushes out 4 bytes, which the interpreter will convert to 8-byte floating points. It is fast and efficient. So we call that function here and have data in B variable. How much? We have 41 years times 30 days times 24 hours, meaning 29,000 hours of data. In this particular download, we had 2 wind components, 27 latitude values and 62 longitude values. So it's a grid covering the Baltic Sea, giving us 98 million numbers, which is of course peanut for APL. We only need to reshape it here into a 4-dimensional data cube. And then we are ready to write it into a file, creating here, together with other components like wind speed, wind direction, temperature, wind gust, sun height, wave direction, blah, blah, blah. We have it all. And we will get eventually a 3 gigabyte data file. I try to, using Adrian's excellent graphics, we can do some statistics on that data. For example, here we split up the wind speed in segments 0 to 5 meters, 5 to 10, 10 to 15, and 15 to maximum. This is outside Stockholm. And the important thing here is we want to see in which directions the wind generally goes in November and with what strength. And clearly we see that from south is the dominating wind speed. Also, we have the wave directions here, and clearly we can see that waves don't follow wind exactly. Mostly we are interested in the stormy weathers, and they are quite rare, and clearly it's mostly from south. This is going to limit or narrow our calculations very much. Then we have actually a lot of, well, let me show you. I'll try to show, let's see if Zoom can take this visualization of how the weather moves. I know I could select video optimization, and this is not hugely important, but if you can see anything here, you see it becomes lighter and darker. It's day and night cycles. You see something green in the background, probably that's air moving according to the weather data we have downloaded. You see a date up here, it's 1979 at the moment, advancing all time with 1 hour. And you see these white lines, perhaps they are wave heights with a blue number, usually between 0 and 5. These are wave heights, and the yellow numbers are wind speeds. Here you can see a mass of air coming from Denmark towards east, and when there's harder wind, the background goes yellowish and reddish. I like to visualize things this way because actually we walked through 100 million numbers, and I want to see that they are correct. What if I make a 90-degree error without realizing it? Then everything goes wrong. Terminating that.
5 minutes remaining. 4.
Yes. And showing what exists in Stormwind at the moment. The next version of Stormwind, the simulator, the VT simulator, is going to triangulate the seabed and all land, all of Finland. And we have collected all depth figures, all depth soundings available freely that one can possibly collect, and are making a triangulation of the seabed. So here I just press the arrow keys up and down, and it recalculates on the fly. This is part of the data manufacturing process. And here it seems we have Helsinki. It's combined with ortho images. And this is very useful to estimate where something may have happened when the sea was 5 meters higher than now. It's not only about tracing old ships, it is also about modern autonomous movement in the archipelago. For example, airplanes in the future will, the airspace will be divided into cubes. And when an airplane wants to fly from one city to another, it's going to rent a set of cubes for some time, and it's going to be computerized. The same with the seabed. It's going to be divided by some kind of logic. So mastering the geometry of the surrounding is not a waste of time in any way. One more parameter, Tomas Gustafsson law. It's strictly forbidden to document the seabed because of well, it's valid for all countries in the Baltic Sea. So I don't know how to do it yet, or how much. I will finish this presentation with another simulation. Actually, it's a short visualization of what we do with brute force. We try to set the ship from Lübeck to go at all possible times and many possible ways. We walk through brute forcely and see what is possible and what is not. And that way we will be able to exclude. So if you look carefully, you can see, I hope you can see a small circle down left moving through a set of waypoints depending on the winds. This is the sail ship, and we take into consideration factors like can they sail in the night, for example, what are the capabilities of the ships, what speeds do they reach, and what do they see, what kind of decisions might they take. These are all estimations, and but it gives us weights, like it's statistical estimations for what is most likely and what is less likely. And as I said, at the same time, we produce code and get data that might be used for something completely different. So I'll finish with this question. I told you I have no answers, only questions. So if you have any ideas where the ship is, please call me and tell me. I'll be happy to.
That's what I was going to ask. I mean, last year you got it down to a few kilometers, right?
Right.
This time it seems like the quality of the data is not quite as good. Huh?
No, it's a bit further back in time, unfortunately. So yes, this was more like triggering your minds. Invent your own solution. Maybe you have better ideas. Here, this is what we have, and I'm not a problem solver. I cannot. I'm not clear. You know, one with a crystal ball. Unfortunately, but that be easy. So this is about attacking, and absolutely about using APL to extend your mind.
Okay.
It's buried, need to try finding it in new dimensions. Yes, absolutely. That's why we have the depths, the bottom triangulation, because that affects the volumes between the islands. For example, effect on how much water can move per time between them. Also, if it ever exists, which we cannot be sure of, the ices and so on may have been going hard on it.
Yeah.
So,
okay, well, we look forward to hearing next year that you found it, right? That's how it worked last time. You came and told us you were looking, and then you found
I can tell you that if you find it, you don't need to hear it from me. You will see it in the 10 news in television, and you will see it each day during 1 week.
Okay. Yep. Well, good luck, and thank you very much.